All right, so let's factorize this. I mean, there are many techniques we can actually use. 2 marks. I think many students will actually use this technique where they multiply the first term by the last term, and so they'll get what? 20x squared. Now we want to find the factors of 20 that will actually, when we add them, give us a -9. So let's look at this. We have 1 times 20 will give us 20. We have 2 times 10 will give us 20. We have 3 times nothing, nope, no integer, multiplied by 3 will give us 20. 4 times 5 will give us 20. And we want to, when we multiply these two integers, we should get 20, but when we add them, we get 9. So it looks like this one, correct? Let's see. But we don't want just 9, we want -9. We want -9. So it means, therefore, that we can't use 4 times 5, but we'd have to use -4 times what? -5. By the way, -4 times -5 will give us +20. Negative times negative is positive. And when we add -4 to -5, we'll actually get what? -9. Remember, if you're adding negatives, you get more negatives. If you're adding two numbers that are negative, then you add the numbers and keep the sign. As in, you add ignore the signs, add 4 plus 5, get 9, and keep the sign, -9. So negative plus negative will give you more negative. Negative times negative will give you positive. So now, basically, remember this should be x here, because -4x times -5x will actually give us our positive 20x squared. And we call this the product. And when we add these, we call it the sum. Hence, we call it the product sum method of factorizing quadratic expressions. By the way, I should put the x's here, right? Remember, it's actually x, -4x and -5x. When we add them, we get -9x, which is the middle term we're looking for. To write back the first term, which is 5x squared. Then the middle term, remember, we're going to separate it into what? Into two parts. With two parts we're going to use. We're going to use -4x and -5x. So we're going to say -4x plus -5x. Writing like this without the plus sign still means that we're adding -4x to -5x. In fact, each term is basically added here. So I basically replace the -9x with -4x and -5x. Then I put back the last term, which is 4. So all I did was separate the middle term into two parts. But what I'm going to do here is to factorize the first pair, which is 5x squared minus 4x. And what's common is just x. And x into 5x squared will give me 5x, because by distributive property, x times 5x will give me 5x squared. And also, x times 4 will give me 4x. So I have factorized the first two terms. Now, when I factorize the last two terms, so we factorize in groups basically here. When we have 4 terms, we factorize in groups. Factorize the first group, which is the 5x squared plus the -4x. Now we're going to factorize what? The -5x plus 4. And if you look at it, you can't see a number that's common, even need a variable. And if you can't, then you will basically use 1, because 1 is a factor of every term or number. So we can actually use 1. But 1 what? Do we put +1 or -1? But here's the deal. What we want to have is that whatever is here, we should have it over here. So we're going to just put that there. You know, basically, when we factorize, you should have the same expression in the brackets, okay? So 5x minus 4 in this bracket should have 5x minus 4 in this bracket, and you'll see why. But notice that we want a number outside this bracket here to be a number such that when we multiply that number by each quantity in the bracket, we'll get the two terms at the top. So can we use +1 to multiply 5x to give us -5x? Of course not. We use -1, because -1 times 5x will give us -5x. And check it out. -1 times -4 using the distributive property will give us +4. Negative times negative with positive. 1 times 4 is 4. Now what this does, it allows us to actually factorize further. What I mean by that is that we have two factors here, and we have two factors here. This is one group and this is another group. For both groups, what is the common factor in both groups? it is the 5x minus 4. 5x minus 4 is common to both groups as factors. So we're going to factor out the 5x minus 4. When we factor out the 5x minus 4, from here we're left with x. And when we factor out the 5x minus 4 from this group here, we're left with what? Minus 1. Another way of doing it quickly is just to recognize that what you have in brackets here and here, you put it in a single bracket. And what you have remaining in terms of x and minus 1, you put those collectively in another bracket here. The x and the minus 1. And so we have completely factorized, and that's it. Here's another technique we use, like the FOIL method, which is perhaps faster. Now, here's what they want us to do. They want us to solve this equation. But if you notice, they say hence. As long as they say that, they're talking about using the answer in the previous step. What we have here, 5x squared minus 9x plus 4, is the same up to this point here. This is an expression. This is an equation. Expressions, we either factorize them or simplify them. But equations, on the other hand, we solve. Now, to solve an equation that's quadratic, meaning that the highest power is a 2 on the x variable. The highest power must be a 2 for it to be quadratic. And once that's the case, like in this case, it must be equal to 0 for us to solve it. Since it's already equal to 0, we can move right ahead and solve this. Now recall that when we factorize this first part here, what did we get? We got 5x minus 4 multiplied by what? X minus 1. So this 5x squared minus 9x plus 4 is actually 5x minus 4 times x minus 1, which is equal to what? 0. So what we do, we recognize that we're multiplying two numbers. P multiplied by Q gives us 0. And what this means? It means that if P times Q equals 0, then either P is 0 or Q is 0. So one of these expressions must be what? Equal to 0. So when we multiply that expression means 0 by the other expression, we'll get 0 because anything times 0 is 0. So either this one is 0 or this expression there is 0. All right? The expression in the bracket, that is. So what we're going to say is this. This will help us to actually solve for x because we're saying that either this expression, the first one, 5x minus 4 equals 0, or it could be a case where x minus 1 is equal to 0, or both. But what this does though, it's help us to derive a linear equation, an equation where x has a power of 1. And once that's the case, we can just transpose every number from the equation and leaving the x isolated. So let's do that. So we're going to leave the x isolated by transposing each number over the equal sign. This minus 4 goes over the equal sign as positive 4. So it's 0 plus 4, which is 4. Another way of seeing it is that we want to get rid of this minus 4, so we add 4 to this side and it's cancelled out. Minus 4 cancelled out by plus 4. And we also add 4 to this side. And so we're left with 5x on this side since the negative 4 is cancelled by positive 4. And 0 plus 4 is 4. Notice that we have the same answer, right? 5x is equal to 4. 5 times a number gives us 4. What is that number? Well, what we need to do to get rid of a number that multiplies the x, we divide by that number. So 5 into 5 goes once. We're left with x. And 4 divided by 5 can be left as a fraction. So x is equal to 4 over 5. So now we have x minus 1 equals 0. So transposing this minus 1 to the other side, we have x is equal to positive 1. We could simply add 1 to this side. And adding 1, if we add 1 to negative 1, right, they will cancel to 0. So this will cancel out to 0. So we only have x on this side equal, and we also add 1 to this side. 0 plus 1 is 1. So it's another way again. But we realize that, hey, we actually have the answer for x here. So x is isolated now, so that's our answer, x equal 1. So our two solutions, x equal 4 over 5 and x equal 1. W is equal to 5 plus v all over v minus 3. To make v the subject, what we need to do is to isolate v. But notice that we have two v's, so which one? That's a good question. Well, here's what we're going to try to do is to get v factored out. Let's say I have 3x plus 5xp. Realize I have two x's, right? If I factor out the x, what am I left with? 3 plus 5p. You know this by distributive property. X times 3 is 3x, and x times 5p is 5xp. Okay, so notice that I only have one x term. So that's exactly what we're going to do with the v, because we have two v's. So we want to bring them together as terms and factor out the v. So here's what we're going to do. What we can do, we can just multiply by v minus 3 on both sides. So that to this side, so it cancels from this side. But we also multiply this side by v minus 3. And when we do that, we can just multiply out the bracket. So w times v is w of v. And w times 3 is what? 3w. And all we're left with on this side is 5 plus v. So what we're going to do now is to get the v terms together. To get the v terms together, we're going to transpose this v over to this side. So we have wv, and this v goes over as a minus v equals 5. This negative 3w to the other side, it becomes a positive 3w. Now what we're going to do is to factor out v. So what we'll get, if we factor out v, we have v outside. V times what gives us v, w. And v times what gives us v, a 1. So we have 5 plus 3w. Notice that we have v isolated now. Only one v at this point of the equation. So since we only have v there, what we want to do, w minus 1 is multiplying v. So to get rid of it, we divide. So w minus 1 divided by w minus 1 will be 1, right? Any quantity into itself will give us 1. And 1 times v is v. Now what we do to one side, we do to the next. So we're going to also divide this side by what? What did I do to this side? I divided this side by w minus 1. So I have to do the same thing to this side. Divide by w minus 1 as well. So now we have what? V. Notice that we actually have v by itself now. V is equal to 5 plus 3w over w minus 1. So v is now the subject. This is our answer. All right, so this part of the question, the height of an object is directly proportional to the square of its perimeter. Write an equation showing the relationship between h and p. So h represents height, correct? P represents what? Perimeter. And the key thing is to look at what we're talking about here, direct proportion. Or another name for direct proportion, or directly proportional, usually say what? Instead of direct proportion, we'll say direct variation. These are the same, all right? And we usually use this little alpha symbol. So the height of an object is directly proportional. So let's write that out. The height of an object is directly proportional. And when we say direct, we usually put just as what they say afterwards. So it says the square root of its perimeter, the square root of p. We want us to show a relationship between h and p in the form of an equation. So we just simply put h is equal to, and we want a constant. We want a constant of variation, a constant of proportionality. All right, so the constant of variation. All right, constant of variation is what we usually typically use k. So I can say h is equal to k with the square root of p next to it. Okay, so we just change this little symbol to equal k. All right, change the little symbol here to equal k, and this is the equation. It says given h is equal to 5.4 when p is equal to 1.44, determine the value of h when p is equal to 2.89. So what they're doing here, by giving us the values of both h and p, is to help us to find the constant of proportionality, k. Okay, so let's see that. So what first I'm going to do is to write the equation. So let's write the equation. That h is equal to k square root of p. This means h is directly proportional to the square root of p. And we use k there as constant of variation or proportionality. So when h is 5.4, all right, let's leave back k there, square root of, and p is what? 1.44. So what we're going to do now is to find the value of k. So what we can say 5.4 is equal to k multiplied by the square root of 1.44 is 1.2. To find k, we divide both sides by whatever is multiplying k here, which is 1.2. And so k, the constant of variation, will be equal to, just give us 1. K is isolated here. And 5.4 divided by 1.2 will give us 4.5. So the constant of proportionality is 4.5. Writing back the equation, we know that. So h is equal to 4.5 square root of p. Now we can use this equation now to find either h or p given 1. So in this case, we're given p, and we're asked to find h. So we know that h is equal to 4.5 times the square root of p, and in this case, p is 2.89. So 1.7, you already have that in your calculator, times 4.5 will actually give us 7.65.